x squared equals x plus 2, right? They have to be the same because y and y. For this point, both functions have the same height. For this point, both functions have the same height. That's why we set them equal to each other. It's because we're using substitution. So quadratic, I move everything to one side, set equal to 0. Okay? So always remember, you cannot solve in any other way, either factoring or quadratic formula, or you plug it in the calculator. So can anyone give us the factored form? So we can quickly determine
-2 x plus 1.
x plus 1. Brilliant. So x equals 2 or x equals -1. So this is at -1 and this is at 2. That's all I needed. How do I determine this area now? Can anyone tell us what to write? How do I write this area? Please try.
Definitive -1 to 2.
Exactly. -1 to 2 from above minus below. What is the above?
X plus 2.
Very good. Minus below.
X squared.
That's it. That's all I need to determine. Which function I differentiate to get x? Which function I differentiate to get x?
X squared over 2.
Very good, awesome. Plus 2. Which function I differentiate to get 1?
X.
Very good. Minus. Which function I differentiate to get x squared?
X cubed over 3.
X cubed over 3. Thank you so much. Again, I have to plug in 2 and then subtract when I plug in -1. So I'll do it again with the calculator. I'm not lazy. I just would like to get to section 4.5. No, that's not what I meant. Okay. So -1 to 2. And then we have x plus 2. The area enclosed cannot be negative. Unless it's a function that is under the x-axis. Okay, so we got 4.5. Good. Do we feel like practicing with another problem like this, or can I talk about a formula? We will practice more, of course, but let me know. So value, average value of a function on a interval, of course, closed. So the average value for a function or a closed interval between a comma b, and the function, let's say it's f of x, it's 1 divided by b minus a, and the integral from a to b from f of x dx. So this is a formula. So for example, if I have the function the rate of change of the temperature, let's say. And I'm sorry, the temperature function, and I would like to determine an average temperature between 6 a.m. and 2 p.m. This is how I do it. So let's apply it in any application you want to pick. So here it is. It's on the next page. The first set of problems. Find the average function value over the given interval from 34 through 44. Please choose any problem you want so we can determine the average value of a function on a given interval. We want to illustrate the formula with any example you want to pick. From 34 to 44. No one wants to choose? Then I will. Okay, I will choose 39. In 39, we have f of x equals x squared plus x minus 2, and the interval is 0, 4. We are asked to find the average value on the interval 0, 4. And the formula requires us to write 1 over 4 minus 0, well, it's just 4, and the definite integral from 0 to 4 from this, x squared plus x minus 2 dx. Very easy formula. I think you find that very easy, I hope. So 1/4 in front. Which function I differentiate to get x squared? You already told me several times today. I'm going to just move on. So you said x squared over 2 and minus 2x from 0 to 4. Luckily, I only need to plug in 4 because when I plug in 0, everything is 0. So 1/4, 4 to the third, 64 divided by 3. 4 squared, 16 divided by 2, and minus 8. So luckily, this is 64 divided by 4. It's 16 divided by 3. So the average value of this function on the interval 0, 4 is 16/3. That's how we apply the formula. Okay, let's look at a word problem. Okay, 47. Again, accumulated sales. Music Manager estimates that monthly revenue, R of T, given here, in thousands of dollars, attributable to its website T months after the site was launched, is given by. Okay, so in 47, I have R of T equals 0.5 e to T. Okay, find the average monthly revenue attributed to the sales for the first 4 months of operation. So from 0 to 4. How do I determine the average value here? Average value on 0, 4. I didn't mean to choose the same interval. So obviously I have 1 over 4 minus 0, and then the integral from 0 to 4 from 0.5 e to t dt. Okay, I'll take 0.5. 0.5 is 1/2. So 1/2 times 1/4 will be 1 over 8. Now, which function prime will give us e to t? And then I will evaluate it from 0 to 4. Which function I differentiate to get e to t?
E to t.
Of course. Thank you very much. So we have 1 over 8. E to the 4th minus, you already told me, e to 0 is 1. And this I will just calculate here. and I have 1 divided by 8 multiplied by e to the 4th, and then minus 1. I got 6. What was the measurement unit? In thousands of dollars. So 6699.77 in thousands of dollars. That's how we apply the formula for in any situation. If we are given a function, we are given an interval. To find the average value of that function on the given interval, we have 1 over b minus a, the integral from a to b, from f of x dx, or from f of t dt, or from r of t dt. That's how we apply the formula. Any questions? I don't know how far we can get into the last section of this chapter, but we'll try. Slowly but surely. Page 7. The last section of chapter 4 deals with the substitution rule. What is the substitution rule used? It is used when it simplifies something. If it doesn't simplify, I'm not going to substitute. So for example, if I want to solve x to the 4th minus 2x squared plus 1 equals 0, I will definitely substitute x squared or replace x squared by t, because this one is t squared. So now t squared minus 2t plus 1 is easier to solve. Now I will have to agree if you say, but I will use a calculator here, and I don't need to do this. True. But this is the point I'm making. The only point I'm making here is I will use a substitution if it makes the equation or whatever I'm determining easier to solve. So let's see how that works. I'm going to choose a problem. I need to look in the books and see the page number. And the page number is 434. So 434, 434, enter. So in this section, we are going to see if we can simplify an integral that otherwise will take us a long time, or it may be too difficult, if we can simplify it. And I would like us to start with simple examples, or from the beginning. Let's choose between 1 and 12. Would you like to choose between 1 and 12? If not, I will. Okay, I'm going to start with 3. The integral from x squared minus 6 raised to power 7 times x dx. So there is a complicated situation here, because if you ask me to take this to power 7, it will take me a while. It's not impossible, but it will take me a while to get those 8 terms, and then distribute x, and then just find the family of functions, because this is the indefinite integral. But it is easier to say, let x squared minus 6 be, or let u be x squared minus 6. It doesn't matter if you say x squared minus 6 equals u, or u equals x squared minus 6. Okay, that is our substitution. So if I use this substitution, then this quantity will be replaced by, anyone would like to tell us what will this be replaced by? If I say let u be x squared minus 6. What will I replace x squared minus 6 to the 7th power by? Anyone, please?
U to the 7th.
Absolutely, that's all I want you to say. So all this will be replaced by u to the 7th. Now, if you remember, I said that so many times that probably you got tired of it. If the integral has the function in x, then I have to have dx. If the integral has the function in u, then I have to have du, and so on and so forth. So this, jumping over this integral now has u to the 7th. Now, I cannot have u and x in the same integral. So now I have to see what happens to this, and I have to know or try to determine dx. I mean, change dx into du. So here's how we do it. Remember, this is a function, x squared minus 6. Its derivative will be 2x, but I don't want its derivative. I want its differential. And we discussed that, so these are the side notes. We discussed that many times in the past. So let me refresh your memory. So if I have a function that is 3x to the 4th plus 2x, f prime, I know you will tell me 12x cubed plus 2, but dy is 12x cubed plus 2 times dx. So this is a differential, and this is a derivative. They're not the same. So once we use the substitution x squared minus 6, can anyone tell us how much is du, the differential of this function?